So how do we use electronegativity to predict atoms' behavior? We saw electronegativity and value and everything, but how do we use it? Well, we purely look at the difference in the values between two electrons. Larger the difference, something happens. Less, more the difference, something else happens. Not so large the difference, something else happens. So let me put it this way. What threshold value should we keep in mind when we're talking about the electronegativity and the bonding and everything? Well, the value is 1.7. If the difference is more than 1.7, it leads to ionic bond. I hope you guys remember ionic bond, wherein we have complete transfer of electron or electrons. Less than 1.7, it leads to covalent bond. Herein we have electron being shared. There is some kind of sharing. And when the difference is 0, this leads to something called as non-polar covalent. It's a covalent bond, but it's non-polar. Here it is, combination of polar and non-polar. So I don't want to confuse you guys with this, but it's pretty important because when we talk about water, we have this polar covalent bond and all of that. And water is the fundamental thing that we need and we respect. So she is our goddess and all of that, right? We have to treat water that way because that's the source wherein we came from. Now, anyways, coming back to this, 0, if the difference is 0, we are looking at equal electron sharing. Okay. And example is, for the large one, it is to do with sodium plus chlorine, right? Chlorine pulls sodium's electron completely. Wherein we have some kind of sharing, but not exactly, full-fledged equal sharing. That happens with water, which I mentioned, in the previous slide. 0 is to do with, say, oxygen or H2 or O2 or whenever we see that, we are looking at non-polar covalent. So there's equal electron sharing. Okay, so I'll go through the slides once more for you guys.